make that process running at all the time effectively, we are maximizing the CPU utilization by having a proper CPU scheduling algorithm. So first of all, what is a fundamental basis for making any scheduling is by using a scheduler. And at the same time, the scheduler have to use all the computer resources effectively before it is going to be used. And now coming to the CPU input output burst cycle. So only based on this, we can calculate and also we can schedule how the CPU process has been carried out. So in order to do that, we need a proper CPU input output burst cycle. So what is this CPU input output burst cycle? Process execution consists of a cycle of CPU execution and input output wait. So when the process is carrying on, it alternates between these two states. So either it can be in the CPU burst or it can be in the input output burst. When the CPU is doing some work, it goes to the CPU burst and that is calculated as the CPU burst time. And when the input output takes over, it goes to the input output burst and so on. So eventually the last CPU burst will end with a system request to terminate the execution rather than with another input output burst. So this is how CPU input output burst cycle carries out. And this is the diagram for representing this cycle. So first CPU burst is it is loading and it is storing and doing some operation. So that time is taken as a CPU burst. And now when input output is doing some task, it goes to input output burst. So like this alternatively, both the CPU burst and input output cycle goes on. So based on this only, we can have a proper CPU scheduling. So who is going to do the scheduling? The short-term scheduler. So this is one which is going to carry out what process should be selected so that the CPU utilization is going to get maximized. So in order to do this, it uses a ready queue, which is not necessarily a first in, first out queue. It may be a first in, first out queue, a priority queue, a tree, or simply an unordered linked list. So before we go into the scheduling algorithm, we should know what are all the types of scheduling we have. We have preemptive scheduling, we have non-preemptive scheduling. So what is preemptive scheduling? So preemptive scheduling is the process when some process is carrying on. If any other process comes, the operating system can take that process out and it can take the next process and it can make some changes. So that is what is preemptive scheduling. Non-preemptive scheduling is there is no preemptive in the scheduling. So once it has taken a process, it have to complete all the process and then only the execution goes on. Now coming to the CPU scheduling algorithm. So we have four types of algorithm: first come, first serve, shortest job for scheduling, priority scheduling, and round robin scheduling. CPU scheduling. Now coming to the first one, first come, first serve scheduling. So what is this first come, first serve scheduling? Whatever the job comes first, so it is going to take it from the scheduler and it is going to get processed. So this is what is first come, first serve. Suppose we have process P1, P2, P3 and burst time is 24, 33, 24, 3 and 3. How the first come, first serve enables. So we need a Gantt chart for that. So first we are coming, the time for drawing the Gantt chart is 0. The process P1 carries out till 24 and now comes P2. Now already we have 24 and P2's burst time is 3. So 24 plus 3 we have 27 and again P3's burst time is 3. So again P3's P2's is 27. So 27 plus 3 we get 30. Now we are going to calculate the average waiting time and average turnaround time. So what is the waiting time? So 0. So P1 doesn't wait for no time. So 0 and P2 was waiting for 24 milliseconds and then P3 was waiting for 27 milliseconds. So everything add together and divided by 3, we have 17 ms. And now we have to calculate the average turnaround time. So what is the turnaround time? The job which has been completed. At what time the job has been completed? So it has been completed. P1 has been completed at the time of 24, P2 27, and P3 30. So everything add together divided by 3, we will get the average turnaround time. But this FCFS algorithm is particularly troublesome for time because it deals with sharing the system. So where it is very important is that you should have to share some of the CPU at regular intervals. So in that point of time, it is a troublemaking when it comes to first come, first serve because all the process have to wait for a long time. Only for whatever the first comes. So that was what is first served. So that you're going for the next schedule called shortest job for scheduling. So the CPU is assigned to the process that has the smallest next CPU burst time. So now we have process P1, P2, P3, and P4. So this is the burst time. 6, 8, 7, and 3. So here out of all the 4 process, we have the P4 process as a very less burst time, which is very less, that is only 3. So now you're going to take in the Gantt chart, which one is the shortest job first scheduling algorithm and which process has the shortest job. So we have P4. So P4 comes to the scheduler first. So 0 at 0 seconds. So till 3 milliseconds it is running P4. And now come to the next process, that is P1, which is 6. And next is P2, P3, and then P2. So this is how the shortest job first scheduling works. Thank you.